So we are conducting a significance test for a difference in means. We are looking at the difference between 1 and 2 bedroom apartments. Cohen and Jason are comparing the 1 and 2 bedroom apartments. They have a random sample of 10 apartment types. We're conducting a significance test to see if there is a difference in the true means of monthly rental rates of 1 and 2 bedroom apartments. We're starting out by stating we will test at alpha equals 0.05. Why are we using 0.05? Because it didn't tell us anything else, so we're going to use 0.05. Okay, cool. Now we're caught up. All right. Our null hypothesis is what? Mu1 equals mu2. What would the alternative be? Mu1 does not equal mu2. Now, why is it a not equal to?
Because they didn't say anything other than
Yeah, we're just wondering, is there a difference? So we're just trying to see, is there a difference or not? Now, I want to remind you guys that you could also write this way. You could say mu1 minus mu2 equals 0, or mu1 minus mu2 does not equal 0. Okay, so you could write your hypothesis in either of these ways. I just remind you of that because sometimes in multiple choice problems, you might see it either way. So just want to make sure you guys know that's both of those are appropriate. Now, because we have a mu1 and a mu2, we need to make sure we define them. Mu1, which one should be mu1? Seems like we should do 1 bedroom apartments, huh? All right. So mu1 equals the true mean rent for 1 bedroom apartment. And mu2 is the true mean rent for 2 bedroom apartment. Perfect. Hello. We have stated. You guys have any questions on state?
No.
Fantastic. What's next? Not yet. Calm down. Next. State, then plan. Okay, guys, here we go. We're going to plan. So I'm going to get rid of all that so you can see what's going on here. And yeah, because we're going to need some room for plan. All right, plan. Here we go. Random. Do we have an SRS? We have an SRS of 10 one-bedroom apartments. And we have an SRS of 10 two-bedroom apartments. Perfect. 10% condition. We're rocking and rolling right now. 10 times 10 is 100. Do you think that 100 is less than the population of 1-bedroom apartments?
Yeah.
I would think so. Probably a single apartment complex has way more than that. 10 times 10 is 100, which is less than the population of 2-bedroom apartments. All right, we've checked random. We've checked 10%. What's left? Normal. This is fun. I love normal. Normal conditions always super fun and easy.
No.
So, did the problem tell us that we have populations that are normal?
No.
Nope. Do we have sample sizes bigger than 30?
No. My dog.
You guys, what do we get to do today on a fun Friday? Not 1, but 2 box plots. Let's go. You guys, I'm going to show you how to do them at the same time. Are you ready? All right, here we go. First thing we need to do is go to our calculator and put the data in. How do you put data in your calculator? Stat edit. All right, where do you think you should put the 1-bedroom apartment data? L1. Where should you put the 2-bedroom apartment data? L2. Go ahead and plug in your data. This is so exciting, you guys. We're making parallel box plots on our calculator, y'all. It's like the best day ever. Yes. Oh. Plugging in our data. Stat edit. L1 is the 1-bedroom apartment data. L2 is the 2-bedroom apartment data.
It's like you watched that basketball game.
The what?
Did you?
Stat edit. We're putting in the 1-bedroom apartment data into L1. The 2-bedroom apartment data into L2. Right? All right.
Forgot one report.
How do you clarify that?
If you go up to the L1 and highlight it.
Maybe this is including having roommates.
Oh, well, okay, so if you've already spent money.
Yeah.
Hit the other.
This has to be. Like, there's no way like they would
Okay,
actually.
just hit the one. No, otherwise, what you can do is you can go up and you can get clear on that. So just delete out the other ones. All right, does everybody have their data in? All right, stick with me here, kids. Are you ready? Here we go. You're not ready? You're ready? You're just messing with me? All right, I see you. Okay, here we go. Stick with me. Second, y equals. Hit enter on number 1. Hit enter on. Down arrow to type. Right arrow to the box plot that shows outliers. Hit enter on that to make sure it's selected. X list should say L1. Bless you. All right.
The one that shows outliers, the first one?
The one that shows outliers is the first one, yes. All right, let me say that again. We went to second y equals. We hit enter on number 1. We hit enter on. We hit the down arrow to type. We hit the right arrow until we got to the box plot with the outliers. That's the 4th one. And double check and make sure that your X list says L1. Does everybody see that? Okay, here we go. You ready?
No. Yeah.
Why are we not ready?
What's the
Where are you at?
supposed to say? Why did you do that?
X list should say L1.
Okay.
Got it? All right, here we go. Everybody, again, second y equals. Go down to number 2 and hit enter. Hit enter on. Down arrow to type. Go over to the box plot with the outliers and hit enter to select it. On your X list, that needs to say L2. So on the X list, make sure your cursor's there. Hit second and the number 2, and it should say L2, and then hit enter. You should now see the L2 in your X list, yes? Okay, here's what you're going to do to verify that yours is right. Second y equals. Look at that screen. You should see plot 1 is on, and it should say L1 underneath it. Plot 2 is on, and it should say L2 underneath it. Do your calculators say that? Plot 1 is on, so second y equals, and you should see plot 1 is on and L1. Plot 2 is on with L2. Yes? Yes? Okay, hit graph, zoom 9. Graph, zoom 9. And get excited. All right, so now here's what we need to do. We need to get these box plots on our paper. But what are the numbers for our box plots? If you guys hit trace, you can go left and right and up and down, and you can see all the numbers. Yeah, you can. It's great. Now, what is the lowest number in either one of the box plots?
395.
395. What is the highest number in either of the box plots? 750. So I need an x-axis that gets me from about 395 to about 750. Seems like if we go by 50s, that would be pretty good. So I'm just going to start at 400, and I just know that 395 is just slightly less than that. And then I'm going to go by 50s. $650, $700, and $750. Okay, cool. And then, yeah, I'm just going to basically draw what I see on my calculator screen here. I've got the top box plot, $395, $495, $532, $600, $650. This is so fun, isn't it?
I'm having a blast.
Funnest Friday ever. $495, $540, $622, $675, $750. Okay. So we do need to indicate which one is which. So which one is which? So I don't know if you noticed, but when you hit trace and you start going on your box plot, it tells you in the top left corner whether you're on the L1 or L2 box plot. And so L1 is the one that's on the top. L2 is on the bottom. And so your one bedroom is on the top. So you can just kind of put that somewhere near that box plot and then near that box plot. And then I do need to label my x-axis. What is that? What do those numbers stand for? What's that about?
Sorry.
What are the numbers on the x-axis? Yeah, those are rent prices or rent amounts. Yep. There we go. Cool. Now, so what?
No, I have to.
There's box plots. Whoop-de-doo.
Good. I think that's normal.
Do we see strong skewness, like whisker missing? No. Do we see any outliers? No. So what does that mean?
It's approximately normal.
T procedures apply because these are approximately normal. Yeah, so we can say no strong skewness, no outliers, and so then we can say T procedures apply. Woohoo! Let's go T procedures. We love T procedures applying, don't we? Woo! Wasn't that fun, you guys?
What would be worse if we did all that work and they didn't apply?
Oh boy, that would be terrible. But you know what we would do if one of them was showing strong skewness or outliers? We would proceed with caution. We would still just keep going. That's all.
Wow.
It would just, at the end, we would just say, normal condition fails, so results may vary.
Like on those medicines.
Yes, yes. May cause death, dismemberment, whatever, but results may vary.
Bowel syndrome.
Yeah, it's great. All right, you guys, that was super exciting. Do you have any questions about plan? Perfect. What's next? Do. Let's do the do. This is going to be super easy. Watch this. We're going to use a 2 mean t-test. We're going to use a 2 mean t-test. So in our calculator, we're going to go to stat test. And we're looking for a 2 mean t-test. 2 mean t-test. 2 mean t-test. Which one do you think it is?
2 sample.
Yeah, 2 sample t-test. Good. Which is number 4. We're doing stat test number 4, which is a 2 sample t-test. Now, did we have data or do we have stats? That was definitely data that you put into your calculator. You have your first list in L1, your second list into L2. Your frequency is there. It's just 1. All right, cool. What is the mean 1 compared to mean 2? Not equal to. Are we getting in the pool today?
No.
No, we're never getting in the pool, so no to pooled. And then you can calculate. All the data, you guys. All the data.
What is the mean t-test under?
It would be under statistical tests.
Stat test.
And then,
Is it the same thing as two sample?
yeah, 2 sample t-test. All right, you guys, T. First thing it tells you is what is the t-test statistic. So what did you guys get for your t-test statistic? Okay, perfect. What's the very next line telling you?
P-value
That's your p-value.
0.05.
0.054. Okay, very good. And then it tells you your degrees of freedom. 17.99. Perfect. Yeah, you could probably say 18. That's fine. All right. Now, guys, look at what your calculator is doing for you. Holy cannoli. It's giving you X bar 1. What does X bar 1 stand for? This is the sample mean for the first population, or first sample. So that means that the average rent for 1-bedroom apartments in this sample was $536. Then it tells you X bar 2. What is that? $613. That's the average rent for 2-bedroom apartments. Now, is there a difference there? Yes. There is, but is it statistically significant? That's what we'll look at when we conclude. We also got the S sub X1, which is the standard deviation for the 1-bedroom apartment. That was 82.56. And we got S sub X2, the standard deviation for the 2-bedroom apartment, which was 84.66. That calculator just did all that real fast. I love this calculator. It's a good guy. All right, let's conclude. Our p-value was 0.054. How does that relate to the alpha value? It is greater than. It is slightly greater than. This is greater than the alpha value of 0.05. It is definitely just barely, but it is greater than. So if the p-value is greater than alpha, what do? We fail to reject the null hypothesis. We are failing to reject the null hypothesis. So while we see that the 2-bedroom apartment is a higher average, so they do have different averages, different means, it's not statistically significant enough for us to conclude that there is a difference. So if we are failing to reject, do we or do we not have convincing evidence of a difference? We do not have convincing evidence of a difference in means. There is not convincing evidence of a difference in the mean rental price of 1 and 2 bedroom apartments. It is not statistically significant enough of a difference. Is there a difference? Yes, you can see that, but there's not statistically significant enough of a difference to say that there's a true difference. Now, obviously, you guys, if you want to save money, you should go with the 1-bedroom. But there you go. But 2-bedroom, got a little bit more space, might be a little bit worth it.
You can, yeah, if you get a roommate, split that. If
No,
unless
they
you're
already
really
have a
poor.
roommate or relationship or.
Oh yeah, it's Cohen and Jason.
Cohen and Jason.
Yeah, Cohen and Jason.
All right, you guys, any questions about a 2 mean t-test?
No.
Perfect. You guys want to do another one?
No. There isn't another one.
Oh, but there's not another one.
Thank goodness, 'cause we're only on the first page. On the front.
All right. So let's look at a few multiple choice questions that could come up with a 2 mean t-test. Number one, or this next page is all about this STEM problem here. Number 1 through 3 is all about this problem here, about road rage. You guys have road rage?
Yes.
Daily. All right. A study of road rage asked random samples of 596 men and 523 women about their behavior while driving. Based on their answers, each person was assigned a road rage score on a scale of 0 to 20. The participants were chosen by random digit dialing of phone numbers. The researchers performed a test of the following hypothesis. The mean for the males equal the mean for the females versus the alternative is that the mean for the males does not equal the mean for the females. Are the conditions met for performing a 2-sample t-test? Let's see. Random. Do we have random samples?
Yes.
Random samples of men, random samples of women. Got it. Okay, cool. 10%. Do you think that 10 times 596 is less than the population of men? And do you think that 10 times 523 is less than the population of women? Probably fine. Okay, cool. All right. Population. Does it tell us the population shape?
No.
No, but our sample size, is it bigger than 30?
Yes.
So we're good. Are all of the conditions met?
Yes.
Yes. So we can mark off A, B, C. We can mark off A, B, and C because we just verified that all of the conditions are met. Okay, perfect. So is it that yes, the conditions are met because the large sample sizes guarantee that the corresponding population distribution is normal? Or is it that yes, we have 2 independent random samples and large sample sizes?
We don't talk about population.
Perfect. You guys, what was the first question under normal? Did it tell us that the population is normal? The sample size does not tell us that the population is normal. It tells us that the sample distribution was normal, not the population. I don't know anything about the population, and having a large sample size doesn't guarantee that the population was normal. So it is not D, it is E. By the way, the independent thing, when you're checking the 10% condition, that is ensuring that you have independent observations. Random is random. Large sample sizes is your normal. So yeah, that's E. Cool? Let's look at number 2. Number 2 tells us what the p-value is. The p-value is 0.0202. Which of these is the p-value interpretation? So let's look at these. There is a 0.20% chance that the true mean is between are different. There's a 0.2% chance that the true mean of them are the same. There's a 0.02 chance of getting a difference as extreme or more extreme than the one we got, assuming that the true mean is the same. There's a 0.2% chance of getting a difference as extreme or more extreme than the one we got, assuming that the true mean is different. And there's a 0.2% chance of getting a difference as extreme or more extreme than the one we got, assuming that the true mean road rage score for males is higher than it is for females. Which ones do you guys think we can mark off?
Sorry, what?
What can we disqualify?
A and B.
A and B. Why can we disqualify A and B?
Because we're not talking about range.
Yeah, cool. So look, we're looking at, when we're talking about p-value, you guys, we're looking for this phrase, as extreme or more extreme. The p-value is the probability of getting a value of sample as extreme or more extreme than the one we got. Now, what are we assuming is always true? We always give the benefit of the doubt to the null hypothesis. So assuming the null hypothesis is true, and what is the null hypothesis? That they have the same road rage. So what is the answer? C. Perfect. Type 2 error. Which of the following would be a type 2 error in context of this study? Now let's think about this for a second. If we have a type 2 error, what have we done with the null hypothesis? We have failed to reject it. If we fail to reject it, do we or do we not have convincing evidence for the alternative? Here, I'll write it down. If we have a type 2 error, we fail to reject the null hypothesis. So therefore, there is or is not convincing evidence for the alternative. There is not convincing evidence for the alternative hypothesis. Now, what is the alternative? The alternative is that there's difference. So a type 2 error means we failed to reject the null hypothesis. We said there is not convincing evidence for a difference, the alternative, but there really was a difference. So which ones can we mark off just by the fact that it's not starting off correctly? A and B. Because if we have a type 2 error, then we have not found convincing evidence of a difference. We have not found convincing evidence of a difference. But there really was a difference. But in reality, there really was a difference. So which one is it? D. So the reason that C is not right is because it's saying that in reality they really are the same. That's like literally the opposite of what we're doing. And then, oh my gosh, E? What's wrong with E?
Accepting the null hypothesis.
Accepting the null hypothesis? Oh,
We've never done
we don't do that. Heck to the null. The answer is D.
that. Kind of sure you're
Right? Cool. Questions about this?
Nope.
Perfect. Last page. All right. Aspirin from different companies can have different effects on consumers. To determine whether the aspirin from Excellent Drug Company causes different responses than Simple Drug Company's aspirin, 30 volunteers who are suffering from headaches are randomly assigned to 2 groups. The subjects in one group are given Excellent aspirin, and the subjects in the other group are given aspirin from the Simple Drug Company. The number of minutes required for each subject to recover from the headache is recorded. A 5% significance level test is performed to determine if there is a significant difference in the responses. The data were analyzed with Minitab, and the following output was obtained. So we have here our sample sizes for both was 15. We have our mean for each, our standard deviation for each, and our standard error for each. This line right here is just telling you that we're looking for a difference, and we're taking the mean for Excellence aspirin and subtracting the mean for Simple's aspirin. The estimate for the difference is negative 0.5. That's just the difference in the means that we just subtracted them. T-test for the difference. We're doing a difference that they have. So the null hypothesis is that the difference equals 0. The alternative is that the difference does not equal 0. So we're looking at a two-sided test here. The t-test statistic is negative 0.38. The p-value is 0.3796 with 27.8 degrees of freedom. Which one of these is the appropriate hypothesis? So you should very quickly be able to mark out D and E because they don't have an equal to sign in the null hypothesis. And then this says that we were looking to see if there was a significant difference in their responses. So which one is it? B as in boy. We're looking for not equal to, a difference. Any questions on that one? All right. Number 5. Number 5, which of the following is the most appropriate conclusion to draw? All right, so it tells us the p-value. And the p-value was what? 0.379. All right, and how is that related to this alpha of 0.05?
It's larger.
That is greater than the alpha of 0.05. So what would I do?
Fail.
I would fail to reject the null hypothesis. So I can also automatically mark off A, B, and C. And if I am failing to reject, is it because there is or is not convincing evidence? There is not convincing evidence. Perfect. And type 2 error, again, is what? Not finding convincing evidence, so I can mark off A and B. I can also mark off E, even though E is kind of funny. Not finding convincing evidence of a difference when in reality, there is a difference, which is D.